Problem 10.37. Evaluate sum over I from 1 to 4, sum over j from 1 to 6, I plus j. Let's first evaluate the inner sum. Sum over j from 1 to 6, I plus j. We can break this to two parts. Sum over j from 1 to 6, I, plus sum over j from 1 to 6, j. The first part, j from 1 to 6, I does not change at all. This is basically 6 times I. The second part is 1 plus 2 plus 3 plus 4 plus 5 plus 6. So 1 plus 6 divided by 2 times 6, which is 21. So the inner sum is basically 21 plus 6i. So this equals sum over I from 1 to 4, 21 plus 6i. Now, let's continue. We break this sum to two parts again. Sum over I, 21, plus sum over I, 6i. The first is 21 times 4. The second, we take the factor 6 out. Then we add 1, 2, 3, 4. It's 1 plus 2 plus 3 plus 4 is 10. So 84 plus 60, which is 144. Now let's look at problem 10.38. Part A. Evaluate sum over I from 1 to 5, sum over j from 1 to 5, I times j. Again, let's first evaluate the inner sum. Sum over j from 1 to 5, ij. I is independent of j. For different j, I is just a constant. Take I out. So we have this. This is I times, what is sum over j from 1 to 5? 1 plus 2 plus 3 plus 4 plus 5, which is 15. So this is just 15i. Therefore, this is sum over I from 1 to 5, 15i, which is 15 times 1 plus 2 plus 3 plus 4 plus 5. Another 15. 15 squared, 225. Now let's look at part B. Evaluate sum over I from 1 to infinity, sum over j from 1 to infinity, 1 over 2 to the power I plus j. This is sum over I from 1 to infinity, sum over j from 1 to infinity, 1 over 2 to the power I times 1 over 2 to the power j. Now, given different j, 1 over 2 to the power I is independent of j. So we can take this out and put it here. What do we get? We get sum over I from 1 to infinity, something. And this thing is 1 over 2 to the power I, sum over j from 1 to infinity, 1 over 2 to the power j. What is this? This is a geometric series. The first term is 1/2. And the common ratio is 1/2 as well. This is just 1. Okay, equals 1. Therefore, this series equals sum over I from 1 to infinity, 1 over 2 to the power I times 1. Again, the first term is 1 over 2. Common ratio is 1 over 2. The whole thing equals 1. The answer is 1. In general, if we have a nested sum over I from 1 to m, sum over j from 1 to n, and we have f of I times g of j. For this, we can always do this. Sum over I from 1 to m. F of I is independent of j, so we can take it out. F of I times sum over j from 1 to n, g of j. Then this is a number which is independent of I, a constant, so we can take this out. And we have sum over I from 1 to m, f of I. Isn't this magical? We can switch the order to make it look better. Problem 10.39. Part A. Evaluate sum over I from 1 to 10, then sum over j from 1 to I. 1. Now the index of j depends on the index I. Let's first evaluate the inner sum. The inner sum is just 1 times I, so I. So this is 1 plus 10 divided by 2 multiplied by 10, 55. Now let's see part B. Sum over I from 0 to infinity. Then sum over j from I to infinity. 1 over 3 to the power j. Okay, again, evaluate the inner sum first, which is a geometric series. The first term is 1 over 3 to the power I. The common ratio is 1 over 3. So 1 minus 1 over 3 here. And this term equals 1 over 3 to the power I times 3 over 2. So 1/2 1 over 3 to the power I minus 1. Therefore, the whole series equals sum over I from 0 to infinity, 1/2 1 over 3 to the power I minus 1. Again, this is an infinite geometric series. The first term is when I equals 0, so 3 over 2. The common ratio is 1/3, so 1 minus 1/3. Therefore, we get 3 over 2 divided by 2 over 3. So multiply by 3 over 2, which is 9 over 4. The answer is 9 over 4. Problem 10.40. Bill thinks of a number that equals 1/2 raised to a positive integer power. Let's say 1/2 to a power I. Betty thinks of a number that equals 1/3 raised to a positive integer power. 1/3 to a power j. Bob then multiplies Bill's number and Betty's number. Find the sum of all the positive products Bob can form. Now, I, J are positive integers. So the sum is going to be sum over I from 1 to infinity, sum over j from 1 to infinity, 1/2 to a power I, 1/3 to a power j. This is a function of I. This is a function of j. We talked about this. We can represent it as sum over I from 1 to infinity, 1 over 2 to a power I, times sum over j from 1 to infinity, 1 over 3 to a power j. The first factor is a geometric series. The first term is 1/2. The common ratio is 1/2. So the sum equals 1. The second factor is another geometric series. First term 1 over 3. Common ratio 1 over 3. So 1 over 3 over 2 over 3. 1/2. So the product is 1 times 1/2, which is 1/2. This is the end of the video. Please work on the homework problems and then bring any questions you have to class.